Welcome to a new test and teardown video. This time it's another Marconi for my collection. An electronic voltmeter TF2604. It's not just a voltmeter. Well, it can do AC volts and DC volts, and then it can do resistance. So it's a multimeter, I think I would call it. And there isn't really a lot of switches and stuff here on the front. The first one, of course, is the on-off switch, but then you go straight to 1000 volts. So that's pretty good. This way you don't break anything. So I kind of like that. So that is definitely our volt setting. Oh, and then we go to resistance. The switch is really, there's a super good stable feeling. Very, very classic Marconi, super high quality parts. And this is definitely one of the reasons I like Marconi. It just works after all those years. So that's good. And here is the 0 for DC, and the idea is, because it's of course tube based, it's from about 1966, right? And it's it consists of 5 tubes. One is a diode, 3 of them doubled triodes, and a voltage stabilized tube. You also find 4 transistors. And the transistors there are only for filament regulation. So because different temperatures on filaments, that will also affect how tubes behave, their gain and so on. So the idea is you go into 0, the DC 0, and then you 0 your DC. And then you can of course measure positive and negative DC. If you go to AC, then you need to 0 the AC. This is actually to inject a DC voltage that will 0 out the offset from the rectifier diode. And then you can of course go to your ohms. Very, very good. I want to open this before I power it up and just do a visual inspection on its state. I did clean it up quite a lot with nice warm water. So this is why it may look like it's really nice and shiny and all that. But when I got it, it was not that beautiful. But I really, really like to clean my instruments so they're looking as nice and as presentable for my videos as possible. You gotta enjoy the the 2 probes here. Of course, this is the AC probe. So the AC probe, that is the one that consists of a little diode tube. It should be fairly easy to open this one, and I can't wait to see if that one is working. It is ugly as can be. And the rubber here is sticky and sort of gross to touch. And then there is a ground lead. And this is the DC or ohm probe. And there's actually a switch hidden on this one. I don't know if you can see this tiny little mark here says ohm. And if I do like, then there's now ohm or volts. That's because there is a resistor inside the DC probe. And of course, if you go to ohm, you short circuit the resistor, and then you can of course measure resistance. That switch actually still feel like it's okay. It's getting better now after a little bit of massage. That rubber here is also really gross and sticky. So enough talk. Let's try and see if we can open this one and inspect its state. So let's look a little bit inside this wonderful unit. One side is just all the calibrations. Isn't that just neat? This is definitely something a lot of people could have learned a lot from. Definitely, I like that. And here's the power supply. So here's the low voltage. Oh, let me get some light. So this is the low voltage filament regulator. And there's actually some wires for a big transistor. Yeah, it's that down there. And this is the high voltage regulator. Voltage reference tube and a dual triode tube that is doing the regulation. And then we got a this is the low voltage capacitor. And yes, I don't know if you can see this, but down here it says September 66. So that is the age of this instrument. That was very, very close to 1966, as I imagined. And this is an issue 1 board. Both of those two capacitors, they're in series, C4 and C5. There are 8 microfarad, 350 volts. So that's the high voltage rectifier components. Rectifier and smoothing stuff, and yeah, you see you got the 2 diodes down here, and they look like they're very badly corroded. And also, as you see here, we got no screws in this PCB, so this tells me somebody was here to fix the capacitors. So I just went to my little box of capacitors and look at the size today. It's actually more volts, 400 volts and 10 microfarad. And look at that size. So yeah, I definitely want to change both of those two. And then hopefully we can continue playing around with this instrument. That is the differential DC coupled amplifier tube. So both of those are dual triodes, and of course, since everything here is DC coupled, and as you know, tubes, they drift quite a lot with time and age and all that kind of stuff. And then there's this classic R5 problem, and this is how you handle DC drift. And then you adjust this value here. Somebody was tired of that and put in a trimmer. So that is great. So I expect to be able to trim the DC offsets on that one. So that is all great. Let's just inspect the state of the PCBs. Are they looking any nice and... Yes, they are nice and shiny. Oh, that was definitely a super stinker. So now I put in 2 new capacitors, and here's actually what I always recommend to do when you put in new capacitors. Try and bend them a little bit away from the tubes. I could actually have put this a little bit further that way, because it's just a few more centimeters, and it's actually amazing how much that makes you know, the heating from the tube will heat up the capacitor, and this is really not good for capacitors. You can imagine those really big capacitors mounted very, very close to that burning hot tube. And as you can see, the PCB left its signs about its temperature. And if you look at those capacitors, they're completely leaked and corroded and all that kind of stuff. And when I soldered on these, the smell is just so much it's just so much telling you what was going on here. This leaked capacitor acid, there's just a special smell when you heat this up by soldering. There's this special smells tell you, oops, there was a leaked capacitor. So now I'll try and find some new screws for this, and hopefully we can power it up. I don't think there's anything wrong with this one because it's a low voltage, a low current. There's nothing really dangerous about that. It's further away from the tubes, and it's only driving the filaments. So I don't think that is super important, by the way, but let's have a look. So I feel I'm ready to power this up. I have now shorted the DC probe, and here is my mains entry. This is off. Nothing bad happened so far. There's light, and it is using 20 watts, and look at that. So here's my 0. Definitely not good. It should not be affected by the ranges, not a lot at least. So see, we got probably supply voltage issue, and that one is not responding. That is normal. This is my, I think I should zero my input at C set, right? As far as I understand, but here it's zeroed here. That's interesting. Maybe I'm doing something wrong. And then we go to AC, and then AC 0, there's almost nothing. Ah, that's because, see? Oh yeah, and we can actually AC 0 it as well. So maybe it is right. I just am a little bit afraid I misunderstood the C set then. Maybe we should try and give it some input voltage and see if that works. So here we go with 5 volt DC. Holy moly, how is that possible? So is it that scale or that scale? Now I'm a little bit confused. It got to be the voltage scales, right? So it's that one, but there's also another one out here, 0 to 10 volt AC only. See, that is the trick. This one is compensated for AC, so it's out here. We have the DC, and it is exactly in the 0.5. Let me try and give it one more. 6, 7, 8, and 9. Wow, man. That is not bad at all. So DC is okay, at least in that range. So that is the 30 volt. So 30 volt or 10 and 5. Okay, so we can crank this up to 10 then. And then it's a little bit low now. So let's see if it's drifting. No, 0 is right. So what I could do is change the calibration out here and make that work. I will definitely play with that in a second, but I of course want to play with my funky AC probe. That is the, I don't know exactly what I want to call this, but ugly is definitely one of the words. Yeah, but ugly. So it's going to be fun with the AC. So there's 10 volts. That would be RMS, right? So that means I go 1 kilohertz, and then I go 4 volt RMS, doodly doot, and then output another. Why not? Zero point nothing, and then there is a tiny little response. So that means we have some kind of problem in here, and there's a little tube rectifier in here. I will have to open this one now. And I think I already found it. So either the cable is broken or something else is broken, because normally I try to dim the light a little bit here, but it's not actually that difficult to see. But there's no filament. There's no light in that filament because it's normally very, very nice and bright, the filament in this diode, and because the filaments actually stick out quite a lot down here, and that is quite normal. Well, you should be able to see that light on this particular rectifier tube, and there's no light at all. So now I'll try and see if there's a reason for that. Is there a missing voltage, or is there a blown up tube? Because I don't have any more of these tubes on my little stock. Ooh, that is a good sign. I don't have voltage. Ha ha! Oh, what kind of luck is that? That is something I can fix. Oh man, lucky me. It's those two pins here supposed to be the filament. So what is wrong here? Ooh, there's a wire here. There's probably not. Yes, there's a wire that fell out. Let's look at that. It is that easy. I don't know if that is visible, but that wire here is not connected. What kind of luck is that? Is that because this... Ugh, this is some sticky, nasty... Oh yeah, oh, ooh, doobie. And it is completely burned and yuckity yuck. Oh, gross. Oh, yo, this is not so good. What kind of slime is that? Oh no, this is bad. It's completely dissolved in all sorts of puke. Cable puke. What kind of green, disgusting goop is this? It's like chewing gum. It sticks. There isn't any smell to it. I can't tell you about the taste. I just don't feel like sampling. So I cleaned this up as good as I could. And that cable here is also still... Yeah. I really would like to see if I could remove this rubber thingy here and just move it 2 centimeters up and then redo the cabling here, so it's going to be nice and good again. But I think it's glued or melted somehow here. Maybe I can see, maybe there's a way. Maybe this is some old sticky glue that turned bad. I really can't explain this annoying goop. So here's a better look of the EA52 diode. And here's the top part. And the isolation on this resistor here totally cracked. And it looks like a little bit of water got itself in here and created a little bit of corrosion and nasty stuff right where the wire is. So I need to clean this up a little bit more. I probably need to change the wire as well, because if you move this a little bit, then it will touch here and create a short. So I don't want that. See, I also got my super duper nice capacitor, the ceramic disc capacitors. And note the center part here, there's no silver plating on that. And that's of course because this piece of metal here goes straight through, and this holds this capacitor down here. And then the top part here, there's a round metal part with a little spring in the middle. And if you push down on this one, there's a nice springy function that actually touches the top of this. You can barely see some marks, and this is where this little springy piece of metal touches the ceramic disc capacitor. Remember, this diode here in this whole system works all the way up to 500 megahertz, and it's quite accurate all the way from a few hertz all the way to like 300, 400, 500 megahertz, and then it works much higher up as well, but then it just gets more and more inaccurate. So yeah, I mean, 1966, this would have been a fantastic cool thing to be able to measure RF, the levels and stuff, and then adjust for maximum. I totally love it. I wasn't even born yet. And that tube is so nice. I don't have any of those tubes in my collection, so I really cannot repair this if there's no light in that one. That took a long time. I have now dimmed the light, and you can see, as I said, the filament is very visible in this diode. That is how it's supposed to look. So that's great. I think I've repaired it now. We'll see if we can measure anything. So let's try again and see if we can make it work. Let's go to 10 volts AC. It's of course going through the warm-up, and then I will turn on 4 volt RMS, and then this is 1 kilohertz, and so where are we? We are now on the AC only, right? So that is 10, 5, 4 volt RMS, and it is spot on. So I think we got a winner. Yeah, lucky, it works again. Oh my god, that is great. So one thing is 4 volt RMS, and this is of course going to work because it's quite a lot of volts. So how about we go down to the 0 thingy. Ooh. So this part needs, okay, then it kind of works. So 0.3 volt. Okay, here it gets super duper aggressive. So that voltmeter here needs a little bit of, oh, I was lucky to, no, this is not for normal mortals. It is just way too, well, look at that. So this is 0.3, so how about I give it 0.2 volt RMS. Turn it on, crank. 200 millivolts RMS, that is right. Why are you doing that? Okay. It was just aggressive, so that is point, where are we? AC. So it's gotta be that one, right? 300, okay, it should be here, right? So nobody said this was going to be super duper accurate anyway, but it does indeed give some sort of an indication. So that was 200. Okay, 10, 20. It's not that crazy anyway. Let's play a little bit with the ohm meter. So I'm of course now in ohm. I am in times 100. And as you can see, ohm is this scale up here. So it goes from 0 to 500, and then at the moment it's times 100, so 500 is here, right? So the resistor I put in here is 510. And let's try and see, there's a meter that's a little bit stuck. So I go 0, and then I go to my 500. So yeah, the ohm meter also works, but I got a little bit of a stuck meter, so I think the meter needs to be taken apart and made a little bit of mechanical maintenance. But other than that, I think also clean up the pot meters could be a good thing to do. But it's quite nice to think that it's back to life. Oh yeah, there's one last thing I wanted to show you, because I've been playing a little bit with this probe again. I actually left this running for quite a while and I forgot it a little bit. Now let me turn away the light a little bit like that. So here's, oh man, that is difficult to show. What happens is this probe gets really warm. That's cute, isn't it? So yeah, I really like the thermal image of that one. Let's try and show you the macro capabilities. All right, anyway, thank you very much for watching. I hope you had a little bit of fun, and please come again soon. Bye bye. You're gonna say bye bye too?